So I'm Francesco Cesarini. Started working with Erlang in 1994, full-time 1995, and lucky enough to have been able to work with Joe, Mike, and Robert, and learn everything there was to learn about building systems, which never fail.
Yeah. Hi, I'm Viktória Fördős, actually technical lead of the Wombat project, and I'm coming from the academic area. Previously, I was working on the static analysis of Erlang programs. I contributed to Refactorer and the Paraphrase project that helps you introducing parallelism into Erlang code.
Starting today, I was listening to Sasha's talk, and I said we should have been here right after him because he did a great job at introducing the VM and what helps you make a fault-tolerant system from a VM perspective. And then sat in on the talk after with Torben, and once again, Torben went in and made a very good comment. Languages shape the way you think and reason. So that point, I think this is really where we should take over from these two very important messages. And what we're going to talk about is the lessons learned from developing systems which never fail. How do you get them to scale? How do you manage them, and how do you prevent failure? So how do you, keeping on the theme on high availability systems which never fail?
Yeah, actually imagine that you need to develop a system in Elixir that is highly scalable, concurrent, and never fails. You build it on the top of the Erlang ecosystem, so your boss truly believes you that you should be able to achieve 9 nines uptime.
9 nines, right? Hold on a second, Vicky. Here now, 9 nines. That is 3 milliseconds of downtime per year, and it is indeed it is a myth. It is a myth and an urban legend. But behind every legend, there is a bit of truth behind it. And this truth about the 9 nines actually comes from a press release from British Telecom, and which experienced during, between an initial phase of a project, so within an initial phase of a project and the end of the initial phase of a project, in one of the boards they had a 3-second outage where you couldn't set up any new calls. Then they took the amount of the project and calculated how much that was in years, looked at the number of boards, and came down to this weird 3 milliseconds of downtime. And I think it's, if you actually started counting from the end of that 3-second outage to the end of the initial phase of the project, I'm sure you would have gotten 100% availability there as well. So you need to always take statistics with a bit of skepticism. And indeed, soon after, there was a great quote from the person managing this project, which says, as a matter of fact, the network performance has been so reliable, there is almost a risk that our field engineers do not learn maintenance skills. And you have a system which never fails, and then when it does fail, operations or DevOps have no idea what to do with it. And indeed, I think this 9 nines, after the initial phase of the project, was reduced greatly, and they actually had to fly in engineers to figure out what was going on and help. And I think, from our end, from an Erlang world, we were doing DevOps even before the term was invented or it was considered cool. But from 9 nines, I have to say, from experience, 5 nines availability is much more like it, and that's a few minutes of downtime per year. Including software upgrades. And how do you achieve those 5 nines?
Actually, assume that the same task is given to 2 DevOps teams working with Elixir. As you can see, this team is still working hard, whilst the other seems to be ready and enjoying themselves. Well, actually, what is the difference? So, actually, these guys were coming from the Erlang world, and Erlang developers do not like reinventing the wheels. Actually, reinventing the wheels means less time for beer drinking. So instead, they reuse tools and components, and they build on knowledge and experience from the telecom world.
How many of you actually come from a Ruby background? Okay, I'd say probably. So I'd say about 90%, 80 to 90% of the room. That's actually 80%. I'd say is low. When we were at the ElixirConf in Austin, it was more like 90% at the first Elixir conference, who actually came from a Ruby background. And I think you'll hear Erlang people saying this time after time, that you need to start thinking differently and you need to start tackling problems from a different angle and a different perspective. And I think my favorite example from the Elixir conference was one of the presentations where someone with a Ruby background had gone in and done an Elixir wrapper around Asterisk. Asterisk is software which turns commodity hardware or your laptop into a PBX, into a small switch, and it will help you handle voicemails, it will help you make outbound calls. And they were actually shipping it as a product. And asked, what's the throughput, what's the performance? Very curious because 10 years ago we were working with Asterisk. And the throughput performance was 10 calls per second. And 10 calls per second for that product was perfect. It didn't need to handle more, so there was nothing wrong with that. But that surprised me that it was so low though. 10 years ago when we wrote an Erlang wrapper around Asterisk, we'd actually reached a total of 1,000 calls per second on commodity hardware. Remember, this was pre-multicore. And actually, within that project, by mistake, we were load testing our system to see how much we could handle. And we thought we had the simulators turned on. In fact, we were still connected towards our VoIP provider. And we managed to sync their whole network. We were kicked out and had to get a new VoIP provider. They weren't too happy. But the message is be prepared for differences between the Ruby and the Elixir worlds. It's almost like you're given a Skoda, and you're driving it. It feels like a Skoda, but the actual chassis is that of a Hummer, and the motor is that of a Ferrari. And when you get something which is really fault tolerant but can go really fast, you need to have full visibility of what's going on inside the VM. You need to have full control and be able to act and preempt. And if something has gone wrong, you need to have the data afterwards to go in and figure out what has gone wrong. The complexity becomes overwhelming. And I think this is an example which came from a company called Concurrix. A few years ago, they were merging FreeBSD and Erlang VM, and trying to get a VM which was optimized to run on the bare metal and would scale on multi-core architectures. And this example here was done with Chicago Boss, but the Phoenix framework would apply just as much. And what they did is they took a Ruby on Rails application and rewrote it in Chicago Boss. And this Ruby on Rails application at the time could handle about 40 users per second. They rewrote in Chicago Boss, and so Ruby, it wouldn't scale on multi-core. So no matter how many cores you threw at the problem, the throughput was still the same, 40 users. You could handle 40 users per second. They rewrote it in Chicago Boss, and they then ran it with 2 cores. They got about 60 users per second. They ran it with 4 cores. They ran it with 32 cores, 48 cores, all the way up to 64 cores. No matter how many cores they threw at the problem, the throughput remained the same. And so what they did is they started investigating here. So here on the vertical axis, we got the number of cores, which they tested everything with. On the vertical axis here, we've got the number of users they were able to achieve. And they started investigating why the throughput was what it was, and quickly found a bottleneck in the system. And it's basically a manifestation of Angel's law, which tells you that your fastest, your program will run as fast as its slowest component. And in this case, what they've done is they put a process which acted as a bottleneck. So you had a lot of parallel activities going on. These were all being handled in parallel, one per core. But when they needed to push everything out, everything was serialized through one particular process. So they went in and they removed this bottleneck right here. And when going in and retrying, on one core, they jumped up from 60 to about 400. They ran it on 2 cores. They were able to run about 500 simultaneous users. We went up to 8 cores, about 800, and at 16 cores, so at 8 cores they hit way beyond 1,000 users. So just by running the code on a machine with 8 cores, they were getting 20-fold increase in throughput on a single node on the same hardware as compared to the rooted system. And when we heard from Joe today in 2018, when you start off your Elixir VM, you will have 1 million cores in there. Truthfully, we will be seeing machines with 1 million cores within our lifetime. It's not going to be rocket science. We're getting there. And in order to tackle these machines, you need a new mindset and you need a new way to approach your problems. And I think one of the cores, well, of course, no pun intended, one of the big things you need to think about here is the visibility you have into your systems. And what we've been doing in the Erlang space is everything we've learned in the telco space, which is being applied to the Erlang ecosystem. We've taken those lessons and we've started applying them in a much wider set of verticals. We started applying them in gaming, in gambling, in finance, banking, within the web. And these are all systems which have to scale. They're all systems which have to handle massive peaks and be very predictable under extreme heavy loads. The same features the telco space had back in the late 80s, early 90s. Now, what visibility do we need when we're handling the systems? First of all, you need to have visibility into you need to have metrics, and these are both business metrics and system metrics. So, give me an example. I'll give you an example of a business metric. Assume, how many login attempts were actually made in the last minute in your system. You need to have full visibility. Of these login attempts, how many were successful? That's your second metric. How many failed? That could be your third metric. Why did a login attempt fail? Was it a bad password? Did the user not exist? You need to fill in and have all of this visibility. You then need your system metrics, and that could be, how much memory is your system using? What is the utilization of individual cores? How many processes were created or terminated within the last minute? Because what you're doing is you're overimposing your business metrics and your system metrics to get an idea over what is using resources and what is causing problems. You need notifications and logs, plenty and plenty of logs. And for example, what happens if a process crashes? You've got 100 nodes and a process crashes, and Sasha did a great job at explaining it. You've got a supervisor, a process crashes, your supervisor detects the crash, you will most probably restart that process. Now, that's great, you've not caused an outage. Some requests might have gone wrong, and you've got millions of requests going through a system that accepts it, and you've got hundreds of nodes running. Are you actually capturing that crash and analyzing it, fixing it, ensuring it doesn't happen anymore? It's still a crash, it shouldn't be happening. What about logs pertaining to your business logic? What happens if you get a distributed Erlang port being busy? We were actually analyzing logs the other day on a system which was malfunctioning. And we discovered that within 24 hours, we'd received 5 million distributed Erlang port busy notifications. It was logged 5 million times within 24 hours. You've got a problem right there, and you need to address that problem. It might not be an issue when your system's running. It wasn't, there were no outages within those 24 hours, but you get an unusually high spike or something unusual happens, that would become your bottleneck, and that will cause issues later on. So it's, and there are a lot of these notifications you need to keep an eye on. What if a process has unusually high memory spike or spends too long garbage collecting? These are all things which will disrupt the balance you have in your virtual machine. And there's a third thing alongside so metrics and logs and notifications, which is alarms. I've rarely seen alarms actually being used outside of the telco space, unless we're the ones designing the system. And alarm is nothing other than an early warning that something's about to happen. So it could be that you've got an 80% disk full alarm or a 90% disk full alarm. or 100% is full alarm. Each alarm will have different severities and will require different actions. And all of these actions you go and you take in what we call, in something we call preemptive support. So you're trying to stop the issue before it goes in and escalates. And there are two types of alarms. There are those which actually originate from within the system, and then there are those you will actually go in and generate from outside the system. So assume you have your Amazon, and you're monitoring the number of purchases. If for example, the counter, every time someone buys something, you bump up the counter, and you go in and you monitor that counter, and if within a minute no one's bought anything on Amazon, there's something wrong. You can be sure that there's something wrong. You want to immediately raise an alarm. What you do is you raise the alarm, and you can keep on monitoring the counter. Hopefully some human will come in and look and try to solve the problem. And as soon as you notice that that counter's been bumped up, okay, someone is buying things, you go in and you clear that alarm. So they automatically get raised and cleared as you go along. And these are alarms which you handle from outside of your system. You might have a system called Nagios, or you might have written your own in your OEM infrastructure. Typical alarms which you always need to monitor, for example, include your system limits. What happens if you hit 80% of your number of processes? You've got a limited number of processes in the VM. They're in the millions, but you might have misconfigured it. Or what happens if you start running out of ETS table? You start getting these 80% alarms, you monitor them, and you go in and you change the configuration, and you start throttling the loads you're actually seeing on your system. So these are things you need to think about. Another very common one is a process message queue. If your process message queue becomes too long, and we're talking thousands or tens of thousands of messages waiting in the mailbox to be processed, you have a problem happening. You've got producers which are producing much faster than what the consumer can consume. And once again, that most probably needs human intervention, where you either start slowing down that process, or you start monitoring very, very carefully, ensuring that you don't start getting knock-on effects. So this is all done in preemptive support. You're trying to address and solve the problem before it escalates, before it actually causes an outage. And you need to be there with your head stuck looking at the system 24 hours a day. You go into any of the telco providers, you've got people staring at a screen, and it's either green or red. And if it's red, that means there's an alarm, there's something they need to look at. And these are just simple ideas which applying them to any other vertical would really, really help. And the second is the whole idea of post-mortem debugging. Your load crashes in the middle of the night, and it's automatically restarted, so you don't even have to get out of bed because an alarm is raised, and once it's been restarted, that alarm is cleared. So that's wonderful, that's great. But when you come in the morning, you need all of the data to go in and find what's actually happened. And you need to basically be able to prove, was it a bug, was it an anomaly, or was it just a feature? Maybe your system was supposed to bounce that way. And really, really important is you need to be able to either admit your guilt or prove your innocence, but do that as quickly as possible without wasting any time. And my favorite story in that space is I was supporting a system which was handling millions of SMSs per day, and I get an email from first-time support saying this user is very, very angry. On Sunday, he was subscribing to an SMS notification service where every time his favorite football team scored, he'd receive an SMS. And he received his football scores 4 hours after his team had scored. He was furious, what's happening here? And we got the number, we were able to see the SMSs coming in, we got a unique identifier, we checked, was it, we went in and checked, was this a prepaid customer? He might have been out of credit. No, he was a postpaid, so that's fine. He was allowed to receive premium rate SMSs, yes he was. All of this was logged. Okay, he was, so let's send it to him, and we sent it over to the SMSC, so we passed it onto the network, and received a unique identifier back. And then with that unique identifier, we went in and checked, and hey, oh look, for the next half an hour, for the next 4 hours, every half an hour, we were getting a handset detached message back. So this user either had his phone switched off or was out of coverage. And within 3 minutes, we were able to get these logs, paste them in an email, and go back to first-line support saying, no, it's not us. Tell this user to either change network or keep his phone turned off. had we not had that level of visibility in our logs, we would have spent days trying to figure out what was going wrong, reading the code and whatnot. And this is on a business level. You know, imagine just on a system level when you're trying to figure out how to bug. If your VM is crashed, you know that it's crashed because you've run out of memory. You have historical data on how your ETS table memory usage was, on how your process usage was, your memory usage was. Do you know what part of the Erlang VM actually ate up all of the memory and caused it to run out of memory? Often you don't. I'd say 90% of the deployments out there have no idea how much memory they're using, let alone of different types. So yeah, so what historical data helps you do is, once again, handle your post-mortem debugging, and you quickly prove your innocence or admit your guilt. And if you admit your guilt, what you do is you put safeguards in place, you fix the bugs, and you make sure it doesn't happen again.
Okay, well, actually it was very general.
Yeah.
But now let's see an example from real life. Actually, half a year ago, we were on site at a customer, polishing the new product just before going on live. Well, there we were performing load testing for a large dating site. Actually, their messaging was based on WombatOAM. It was an Erlang cluster consisting of 4 WombatOAM nodes. By the way, have you heard about that WombatOAM is being integrated to Phoenix? In San Francisco at Erlang Factory, Michal and Sonny gave a great talk about it. Check it out on YouTube. So, while we were performing load testing, we noticed that an alarm raised. We found that the system limit is almost hit only on 1 node. Actually, it was exceeding the number of allowed tables, and the question was why? Well, we increased the limit and continued testing. Next, another alarm is raised. We noticed that the mailbox of a process on the same node is too large. Well, it is definitely a sign of an overload. So we analyzed the case in more details and noticed that the Mnesias tables were misconfigured. Actually, 1 node had no local tables, thus the overloaded node took over the load. So as the solution, we fixed the configuration, and voila, the alarms were cleared. Next, another alarm was raised. It was about that nodes belonging to the same cluster use different versions of the MongoDB application. Consider how big would have been the surprise if this problem had turned out on live. And actually, detecting the root cause is not straightforward because the errors can only be found in the logs on the nodes running the wrong version of the application. So, as the solution, we reviewed the release process, and we found that MongoDB were built from source on each node. This is not good, so we advised to use a continuous integration server to build the release artifact and download it from here. Next, we were faced with another alarm. It was actually a module clash. A module clash occurs when a beam with a certain name can be reached from multiple code passes. Well, we were very curious about the reason, how it could happen. And so we reviewed the share history by searching in the log files. And we found that actually one of our colleagues added some code passes to some nodes manually. So as a solution, we resolved the OTP dependencies. Finally, using system metrics, we analyzed the MongoDB driver. So the MongoDB driver was actually a bridge between the persistence and the application. Well, we found that the load wasn't equivalently distributed. Look at this black pot. As a solution, we improved the configuration of the load balancer, and then all the plots were close to each other. Now I'm pretty sure.
Just like to add, all of this was just done probably in about half a day. And we not had this level of visibility, this would have probably gone on for days, trying to figure out what each and every single one of these issues was. That was really, really quick turnaround time, which made it really worthwhile.
Yeah, and now I'm pretty sure that all of us agree that issues not handled lead into outages. And then you can firefight all the day. But actually, this is not good. And this really can be avoided by preemptive support. So preemptive support stop and address issues before they escalate. Actually, the choice is yours. So, actually, have you heard about the Release project? It is an EU-funded research with about 3 million euros. It was a collaboration between European universities and companies. It was aimed at getting the Erlang ecosystem to scale with tens of thousands of nodes. Actually, there, multi-core and distribution goes hands in hand. We call it scalability. There, we experimented with a generic operation and maintenance node that would handle the orchestration in the heterogeneous cloud, and these nodes gave us the full visibility of what was going on in the Erlang VMs. As a result of this project, we developed a product called Wombat. Actually, Wombat is a commercial product, but this does not stop you from taking ideas from it and applying the similar principles in your projects. After all we did was build on ideas from the telecom space and abstract them to other verticals such as gaming, banking, finance, e-commerce, messaging, and others. So, actually, Wombat is able to manage 10,000s of nodes. How was we able to achieve this result? Well, actually, we developed the distributed application even in terms of persistence. We built actually a Wombat tree that uses as many Wombats as needed to fulfill the request. The approach makes the actors independent from each other, thus they do not affect the scalability of the others. And this also brings the fault tolerance into the system. To provide the visibility in your system, Wombat injects agents to the managed nodes. Actually, these agents need to have very, very small effect on the nodes. Consider that your application is ruined by Wombat. No, it is not acceptable. So, as a proof, we measure the execution time of an algorithm with and without Wombat's monitoring. The difference between the measured values is the overhead of the monitoring. We found that the maximum overhead was less than 1.5%. So we consider Wombat non-intrusive. So it can be safely used even in production environment. Besides these, Wombat has many attractive features. Actually, Wombat can become your hub. Wombat can help you to deploy and manage 10,000s of nodes, even in heterogeneous superclusters, even in cloud. It helps you to prevent outages using alarms. Alarms can be directly pushed to pager duty. Wombat has more than 25 built-in alarms, and there are special alarms for React or Mnesia. Besides these, we have more than 100 built-in metrics. These are system metrics. And Wombat can automatically collect any exometer or FOSO metrics as well. Wombat also collects logger and SSL logs. And please note that Wombat doesn't compete with existing tools. It is a complement tool. all we wish to want is to provide the Erlang-specific view of the system. So we support integration to Splunk, Nagios, Graphite, Grafana, and Cacti.
I think the moral of the story is if someone comes to you and says, hey, I wrote my system in Elixir in 4 weeks, beware. Beware of the kind of the whole hero programmer approach. You know, if you ask this person, you know, where's the documentation, and you tell them, and you get it as a response, go read the code, you know, that's the documentation, small alarm bells need to start ringing. Is this the person who gets woken up in the middle of the night when the system fails and no one has any idea what to do with it? And you know, finally, you know, how do you discover that the system has gone down? Is it actually your customers calling you up saying, hey, I can't log onto the website? Or you know, does the DevOps team actually get a notification even before the system's about to go down that, hey, something's really wrong here, it's failing? And you know, when you're thinking of it, you know, when you're developing, you know, in the Elixir space, you know, for your business metrics, you've got you've got Exeter, you've got Folsom. For your logging, you know, you have Logger, and you have even, well, your Elixir Logger, which you should be using. And you know, for alarming, you've got the SASL alarms, where you can raise and clear alarms. It's a very, very simple interface, which you can then, you know, write your own handlers and hook into other systems, such as Nagios and others. Or you can use Elarm if you're writing your own OEM solution itself. So, you know, doing all of this, creating this visibility and doing things properly takes time. It's not a process which can be rushed through, but you always have to start small and then build on your you know, the lessons you're learning when running your system live in operation. You get woken up in the middle of the night, you fix the problem, make sure that you start getting early warnings next time this problem occurs. And I think, you know, in Wombat, every single alarm will have a story over either how, you know, one of our developers had to spend weeks looking for a needle in a haystack. And, you know, looking for a needle in a haystack in the middle of the night when there's an outage is not the most fun of things, believe me. Or you know, stories which have caused an outage. So it's all there as a pre-warning, and you need to build it your own, you know, based on your experiences. So, you know, you know, take everything which is generic, package it into libraries, and then start reusing it. You know, you know, think of Murphy's Law, and think of the lessons learned when telecom systems could not go down. They could not go down because the law stated that they could not go down. Yeah, even in case of, you know, an earthquake or a catastrophe, you still have to be able to pick up your phone and dial emergency services. And secondly, when we were shipping telecom systems, the fines which came associated to outages were massive. And so what happened, you made sure the systems did not go down. So, you know, when you hear about 5 nines availabilities, it does come at a price, it does come at a cost, but it is possible. And yeah, you can do it yourself by monitoring your system through preemptive support, but most important, having full visibility over actually what's going on. Yeah. So, any questions or any thoughts? I think you're coming from a different space where maybe, you know, the throughput and the performance, you know, requirements were very, very different. And it is, you know, it can be a bit daunting at times when talking about it. And interestingly enough, you know, when, you know, we were at the first ElixirConf, there was not one mention about the internals of the Erlang VM. You know, this is all we're talking about in the Erlang space. And luckily, well, the least, you know, the longer you have to wait to be exposed to it, the better it is. But, you know, sooner or later, you know, that thing will come. Okay, any questions? All right, thank you. Thank you very much.
Thank you.